Have you ever looked up at the night sky and wondered about those tiny, moving stars? Chances are you were looking at a satellite, one of thousands, silently orbiting our planet. But how exactly do they stay up there, defying gravity and zipping through space at incredible speeds? Today, we're unlocking the secrets of satellite orbits. First, let's get one thing straight. Satellites aren't just floating. They are in a constant state of free fall around the Earth. Imagine throwing a ball. It flies forward and then curves down to the ground because of gravity. Now, what if you could throw it so fast that as it curves downwards, the Earth's surface curves away from it at the exact same rate? That's an orbit. The satellite is constantly falling, but it's moving so fast horizontally that it never actually hits the ground. It just keeps missing the Earth. This perfect balance between forward momentum and the pull of gravity is the magic behind every orbit. Not all orbits are created equal, though. They come in different shapes and sizes, each designed for a specific purpose. The most common type is the low Earth orbit, or LEO. These are relatively close to us, anywhere from 162,000 kilometers up. Satellites in LEO, like the International Space Station and the Starlink constellation, whip around the Earth in about 90 minutes. Because they're so close, they're perfect for high-resolution Earth observation and providing low-latency internet. Downside: they have a small field of view, so you need a whole network of them to cover the globe. Next up, we have medium Earth orbit, or MEOW, which is the sweet spot for navigation. Satellites in MEOW are about 20,000 kilometers high. Does that number ring a bell? It should. This is where the GPS satellites live. At this altitude, they orbit the Earth about twice a day. This gives them a wider view than LEO satellites and a more stable, predictable path, making them ideal for pinpointing your location on a map. Now let's go way out, to about 36,000 kilometers. Welcome to the geostationary orbit, or GEO. This is a truly special place. At this specific altitude, a satellite's orbital period matches the Earth's rotation period exactly to 24 hours. This means a geosatellite appears to hover over the same spot on the Earth's surface continuously. This is incredibly useful for weather forecasting and broadcasting TV signals. That satellite dish on your house? It's pointed at a GEO satellite fixed in the sky. But wait, there's more. We also have highly elliptical orbits, like the Molniya orbit, named after the Russian word for lightning. These orbits are long ovals. The satellite spends most of its time moving slowly at its farthest point, high above a specific region of the Earth, before zipping quickly around the other side. These were designed to provide communications coverage for high-latitude regions, like Russia, where geostationary satellites are low on the horizon. So, from your GPS navigation to your weather app, and even your TV shows, these invisible orbital highways are the backbone of our modern world. Each orbit is a carefully calculated path, a delicate dance between speed and gravity, engineered to serve a unique purpose. It's a testament to human ingenuity, turning the fundamental laws of physics into technologies that connect and protect our entire planet. The next time you see a satellite streak across the night sky, you'll know the incredible science that keeps it soaring. Thanks for joining this deep dive into space technology. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and hit that notification bell for more space explorations. See you next time!